In this video, I'm going to walk you through lesson 11 of unit 7.1 from OpenSciEd. Okay, this is the lesson where we pretty much figure out the anchoring phenomenon. We are going to figure out that what's in those bubbles produced by the bath bombs is carbon dioxide, but we're going to take 2 days to get there, and let me walk you through how we develop this. So first of all, we navigate into the lesson. Here's the slide to support you. We're going to meet in a scientist circle. We're going to have a talk about what we figured out so far. We're going to use these two posters that we've already been looking at, the manipulative poster and then also the key model ideas. We're going to kind of refresh our memory of where we are. Now, depending on where you ended at the end of the last lesson with the electrolysis apparatus and talking about how particles split apart, you may or may not have gotten too deep into this. So now we're going to try to represent this on the poster. What happened with the electrolysis? How did we split that water particle? So you're going to come to agreement something like this. It depends on how far you went in your last lesson, but you're going to have your water particle. What happens to it is we add some energy and it comes apart to make two pieces, two particles. So you want to add that to the poster, and we're going to modify our key model ideas to add the term chemical reaction. Now, here is something from the teacher guide to support you on how to get there. Go ahead and look at the teacher guide. This is a good moment to really go into that teacher guide and look at the details. But we're going to revise our poster to change the term of making new substances we're finally going to introduce that term chemical reaction. Now, there is an article that comes after this. There is a reading protocol to follow. If you have your own, go ahead and do it. The reading protocol basically has them break up the reading into two sections. They're going to read page 1 for this first portion. They're going to follow the directions in the boxes and reading on the page. They're going to mark up the text and they're going to try to answer the question, how do Dalton's models of the particles that change in a chemical reaction compare to the ones we developed? So we're just trying to make the connections between what Dalton did and what we did. And this second reading protocol is the next slide. And basically they're going to read the remainder of the text and they're going to connect it all together. So when they read the article, and this is what it looks like, you'll notice that I highlighted a few terms. They're going to be introduced to these terms finally. You probably almost started to use them if you haven't already. But the word atoms, or the term atoms, the term compound particle, chemical reaction is revisited again, molecules. So these are some big terms we've been waiting to use. So finally, we get to use the terms atom, molecules, chemical reaction, and compound particle just means that more than one particle is put together. Now, one important thing here is this key to look at how Dalton represented the different atoms that are in water. We've got a circle for a particle of one atom and a circle with a dot in the middle for a particle of the other atom. And so we're really introducing the idea of modeling particles of different substances. So we're going to model atoms. With that lens, we're going to then update our progress tracker. And our progress tracker is really just trying to, again, connect how Dalton's models compare to what we've been doing. And I will tell you that this progress tracker is really valuable to help students process their ideas and come prepared to talk in that consensus discussion. A lot of students need a little bit more time to gather their thoughts before they participate, so that helps them do that. That's the purpose of that being there. Okay, so we engage in a consensus discussion, and we're going to complete a handout as we do this. These are the big ideas that should come out. And basically is that particles are made of molecules and atoms, that molecules are made of more than one atom connected together. There are only a few types of atoms that make up all the different substances. And in a chemical reaction, the molecules that make up the old substances can be broken apart and rearranged to make new molecules of new substances. Those are the big ideas for the entire unit. Okay, now there is a handout to complete as you do this. I will say this is really going to depend on where your students are at the moment. If your students know H2O is 2 hydrogen and 1 oxygen, I'm not sure that I would do this, but it does help to look at the next set of models. Basically, you're just going to be representing, and the teacher guide will walk you through. Is it 1 hydrogen and 1 oxygen or 2? So I'm going to let you look at the teacher guide for this. I think this is something I would cut out, to be quite honest. So really, you're trying to get to these molecular models here, and this is a handout. You can print it out, or this could be on an LMS and you project it on a screen because it's color. It looks a lot better. And you will notice that we're pretty familiar with water. You can make a model with gumdrops. You can make a 2D model. You can make a ball and stick model. If you have a ball and stick kit in your class, it'd be worth taking it out and building a ball and stick model to explain what this is. The structural formula could be written like this. Now, you do not need to get into bonding in middle school. Bonding is high school standards. And so just go ahead and say the atoms are connected together in a molecule. And then we're going to represent, this is a single molecule of the substance, and here's 3 molecules of the substance. So you are going to have 3 molecules of water this way, but if you're writing the molecular formula, you write 3H2O. So we're starting to introduce the numbers here and the coefficients in the molecular formula. So now that we're pretty familiar with how we model atoms and molecules, we're going to participate in a consensus discussion. And really, this is the moment where you're going to look at these different molecules and atoms, and we're going to revisit our ideas that these are the 3 gases that we thought it could be: argon, methane, and carbon dioxide. And we're going to compare them to the substances that could have produced them, which would be citric acid, water, and baking soda. And so we look at what's in these substances and we think, if they broke apart, which gases could they make? And so you will see, here's your key ideas. But really, when you narrow it down, we're going to find out that out of those 3 gases, there's only one it can be, and that is carbon dioxide. So we have now figured out what the new substance is that were in those bubbles of the bath bombs. They're going to use this new idea to revise an explanation of the anchoring phenomenon. Here's the handout you will give them, and you're going to have them draw a model showing where the matter came from at the particle level to produce this kind of gas. So this is a big moment. This is kind of it. There is something here provided on what to look for in the models, but this is the big moment in time. We really have now introduced chemical reactions and what's in that gas that was produced by the bath bombs. Let's talk about the materials prep in the next video.